You will have a binder check. I'm going to start them on Thursday. If I don't get to yours on Thursday, then I'll grade it on Friday. So, perpendicular bisector theorem states, basically, this is a statement. It says, if a point lies on the perpendicular bisector, then it is equidistant from the endpoint of the segment. This is a statement as in P to Q. All of these theorems are if-then format. Basically, if I know that this is a perpendicular bisector, it's cutting it in half. That means that these pieces are also congruent. So as C moves up and down this line, those distances are going to change. The bottom is still cut in half, but those distances are going to change. They're going to get longer and shorter depending on where C moves to. So put AC is congruent to BC. The converse, because this is on your midterm, converse is that same statement just backwards, Q to P. It's kind of like using common sense. If I can use this theorem one way, I can use it the opposite way. If I know the sides are congruent, I know two things. I know this is a 90-degree angle, and I also know the bases are congruent. So I can say CD is perpendicular to AB, and it's also still splitting that base. Sorry. Okay. AD is congruent to BD. What's going on? Oh, snap. Okay, so let's go down. We're not doing all of these. For numero uno, you need to find the value of x. What do you think we're going to do? No, we're not going to equal them to 90. Equal them to each other. So we're going to equal them to each other. We're going to solve for x. So take a second. There's 4 different ways to go about solving this. You're going to set them equal to each other. I'm going to get rid of the negative, so I'm going to add 48. But once again, there's 4 different ways to solve and get the same answer. You're going to need a calculator, so if you don't have a calculator, you should probably come get one because you're definitely going to need a calculator for today. Much is that? Why am I having a brain fart? Is that 72? Yeah. Bless you. Okay, 72 equals 6x. If you divide, what do you get? 12. That was easy. Let's do it again. We're going to skip number 2 and 3. Let's go to number 4. So 4 is technically the converse. So because you know the sides are congruent, then this is a 90-degree angle. The bases are congruent. So you're going to equal it to each other. But when you're done, this one doesn't say solve for x. It says find EG. So when you're done, you're going to take it and you're going to plug it back in because we're going to have to use substitution. So set them equal to each other. Set them equal to each other. Solve for x. Plug it back in.
We solving 2 and 3 later, or we?
No, we're skipping them for now. Don't scribble them out.
All right.
You're not. I know you're not done over there. I know you're not done. You should do it. Some of you are done. When you solve for x, what do we get? What do we get? 4. Because you got to plug it back in. So you get 48 equals 12x, so x equals 4. But that's not the answer because we have to substitute it back in. So EG is this section right here. So this is the part that you don't really need to write out, but I'll write it out. You're doing 2, you're plugging in your x, which is 4, and you're adding 11. So 19. So this section is 19. So EG equals 19. So let's move on to number 5. So number 5 down at the bottom, take a second. You are going to find F to D. F to D is the whole length. You're going to start by setting them equal to each other like you normally would. You're going to solve for X. And then what are you going to do? You're going to plug it back into whole. Equal to each other, solve for X down. I don't know. Think about it. You got a big brain. I believe in you. So what do we get for X? We get 3. Because you get 2x. You get 2x equals 6. You divide by 2. You get x equals 3. Now, when you plug it back in, what do you get for each of these pieces? You get 10. Because 5 times 3 is 15. Minus 5 is 10. So this is 10. This is 10. So how much is F to D in total? 20. So we need to find the next part. We need to find is EG. So that's like the height. It's just fallen over. It's not 90. The angle is 90. 13. That's correct. So you have to do the Pythagorean theorem. So you want to know the height of the triangle. Oh no, it's back again. So basically we're focusing on like half of the triangle. So if I draw this, off to the side, technically if I stand it up straight, how much is the bottom technically? 10. How much is the hypotenuse? 13. The Pythagorean theorem, this is the part of the year, I kind of said this last week at some point. This is where all of the stuff will start combining at this point of the year. We are combining old stuff. We did this like the first week of school. So we're doing 10 squared. I guess I should write the formula first. A squared plus B squared equals C squared. Pythagorean theorem is from middle school. So we're going to do 10 squared. We don't know B. B is over here. And it's equal to 13 squared, which is C. The only one that really technically matters is C. C is always the diagonal on the triangle. It's always the longest side. It's always off to the 90-degree angle. So does anybody remember what I should do to solve the Pythagorean theorem? Good. Okay, hold on. Shh. So we square them. We got to get B isolated by itself. So I got to get rid of the 100. So it's positive. I'm going to subtract it to both sides. And then you square root it. So in the calculator that you should all have, we're going to square root it. So you get a decimal. So what do you get for that last side? 8.3. So this length is technically 8.3. It's not drawn to scale because that side is clearly longer than the other sides. But that's okay. Sometimes it's not drawn to scale, but that is correct. So take a second, flip your paper, look at number 6 at the top. See if you can figure out what to do. It's asking to find the perimeter so you can move around some numbers. Think about what you should do. Yeah. Perimeter is all the sides added up together. So think about how you can find all of these sides. Yeah. Keep going. Yeah. But you're not done with it. Oh, wait, wait. Oh, yeah, yeah, okay. Hey, right. Say my word. I don't check off that. Wait, what? It's, you know, it's one. I know, I don't check this. Basic ones. You're not going to get out.
Yeah, no.
Not putting this. Yeah, it's
Now, the one from the one from the right on this sports. No, I'm so busy.
Because we have other stuff we're doing. This is not the only thing we're doing today. So I'm trying to move
This one's.
through and y'all are taking too long.
Alright.
And that means you're gonna have to. I'll plug this in again. That's where the right side. You're literally.
No, I'm not. I did the, I didn't need it after.
Okay, so if this is 50, where else can 50 go in your picture? The other side, because they match. The other two sides also match. So if I set these equal to each other, I'm not going to write all this out, but I'll set up the equation. If I equal these to each other, what do I get for x? 4. If you plug it back in, you get 35 here and here. How do you find perimeter of any shape? You add up all the sides. So you're doing 50 plus 50 plus 35 plus 35. What do you get for the perimeter? 170. So the last thing we're going to talk about, is angle. Oh my God, Noah, shut up. Jesus. Last thing I'm talking about is angle bisectors. Angle bisectors is like perpendicular bisectors, but it's not going to make a perpendicular line at the base. So this triangle is not literally splitting in half, making a right triangle at the end. It's creating a perpendicular line over here. The reason why is because this is an angle bisector. And so what is happening is it's splitting the angle. It says AD bisects BAC. So it's cutting the angle in half. And then, you know, AB is perpendicular to BD. You need to know these are perpendicular, and this side also has to be perpendicular. Then you can say that these two are congruent to each other. So you could say BD is congruent to CD. The original theorem is your normal P to Q standpoint. The converse is Q to P because converse is going to be on your midterm. You just take the statement and you flip it. It's literally using the same knowledge, just backwards. If you know that these are congruent and you know you have your 90-degree angles, then you can add in your angle markers and justify that these two angles are congruent to each other. So if I say angle BAD is congruent to the angle on the other side, if I put B first, what does B match with? C. B matches with C. If I say A is in the middle, what has to go next? A. And then last but not least, D. So we're only going to do 2 of these because they're easy peasy. We're going to do 3 and 4. So for question 3, it's the same math as the front. You're going to take your segments, you're going to equal them to each other, and you're going to plug it back in to find AD. So take a minute, set them equal to each other. Today's nice because everything's equal to each other.
What is it?
3.
Alright, I just hear me here. I'm just saying that. That's what I'm because in my bed, you
So what do you get for X?
7.
7. What? 3. You get 3. And then you plug it in to find AD. So you're doing 13 times 3 minus 4. What do you get for AD? Is that right? Okay. Try number 4. 4 is finding an angle. So find X. And then I know a lot of you are really bad at reading this. Try to figure out where you're plugging that into. So try number 4. They're going to be equal to each other. And then you have to figure out where it's being plugged into. You have parentheses. How do you get rid of parentheses? Distributive property. So you will have to distribute for number 4. This is like hurting my head. So you will have to distribute.
It's now like invisible, bro. What is this?
So I think the
Yeah, that I. You got extra percent. But we have to look at backwards.
Go sit down.
I'm getting a clipboard.
You're claiming the clipboard already?
Yeah.
Okay, so for this, what do you get for X? You get 7. Most of you are really bad at plugging it in, okay? Because it's 3 letters and not 1. If you start at X, you're going to W, and you're ending at Z. People are like, it's 180 because it's a triangle. No, you're not adding them all together. It is just the middle letter. You are not adding the whole angle together. It's just half of it. So you're doing 8 and then in parentheses 7 minus 4. So what's 7 minus 4? 3. So you're doing 8 times 3, which is what? 24. So it's a little bit different than normal, but this angle is 24 degrees. Did you distribute the 8 in?
Yeah.
You did. That's fine. You could do 8 times 7, 8 times 4, and then minus them. That's fine too. You get that math at this point, like you could do it whatever. So as long as you're using like math rules like distributive property, PEMDAS. Not right now. So the problems on the notes, you do not have to finish. I'll help you in a second, Pepper. You do not have to finish for now. Just leave them blank. We might go back to them. I don't really know. I haven't decided. I don't want you to scribble them out. There are problems around the room. You are bringing your calculator and a binder. You're finding a friend. Each problem leads to a new problem. So if you start here, the answer to this is somewhere around the room. Now, the problem that people are running into, if you find X and you don't plug it into where it's supposed to be plugged into, then the answer is not around the room. So make sure if it's a plug-in problem that you plug it in to find to the next answer. Okay? Go.
I thought Santa was just one. Aren't you Santa?
Let me know if you get stuck or something. Jasmine, I'm coming over to you right now. Give me a second.
What?
Not you.